Okay. All right, so we've got the recording started. And I'm going to see if I can make this full view here. What if I go full screen? Oh, that doesn't make a difference. Okay, well, if you're not able to see what I'm showing on here, let me know. Tell you what, hang on just 1 second. All right, Sean, let me ask you something. This right here, where my hand is that taking up your whole screen? Can you actually read that? You can see the paper without any issue. Okay, and it is big enough for you to actually see what's written on it. Okay. All right. Well, we're going to just go ahead and get started. Okay, perfect. We're just going to go ahead and get started, and the recording of this first one might be a little weird because on my screen it's showing kind of small. So hopefully, um, not full screen. Okay. All right. Well, we'll see what we can do, and I'll just make sure to read fully out loud things that are written in case, you know, somebody's listening later to the recording. So, all right, so right now you're the only one here. Welcome. My name is Maxine. It might show up as Brandy. Brandy is technically my first name, but I go by my middle name of Maxine Horn, learning specialist in the Academic Support Center. So you have a lot of resources available to you for assistance with your stats class. So you've got the the online Pearson, the homework you can go through and do. I think it's called like similar problems, right, where you can do the practice. Your instructor, you can always email them, or I think they'll often have office hours that you can visit them, or give them a call, email, all that. Also, we're going to have these reviews before every test, including the final. And then you can also either go in person to the Academic Support Center at any of the campuses, or you can do the online chat, the virtual chat with the Academic Support Center if you're not able to physically go to the location. So, all right, so today, like I said, we're going to be working on, this is the review homework assignment that covers everything that's going to be on the test in terms of, this is chapter 1 and chapter 2. So I'm just going to go through. We've got, I think it's like 36 problems. We'll get through as many as we can get through. If you want me to skip ahead to like, a particular type of problem, or if you have a specific question, I'm going to keep my eye on the chat. But also, if you have a microphone, I can I can allow your microphone and you can verbally ask me a question if you want to. But like I said, these are recorded. Some people don't want their voice to be recorded, so just be aware of that. So, all right. Also, I'm going to be showing you how to do things on the calculator. I have this beautiful purple fancy calculator. Um, yes, so I'm not entirely sure how I will be posting it. I may be like emailing it, but we will be making the recording available afterwards. So I will let you know. What I'll do is I'll actually just email you directly to let you know what happened afterwards. And and that way you can be sure that you have access to it. But we'll figure out a system so that every review session can be available afterwards. So like I said, this is a fancy calculator. On your in Pearson, they have a I forget what it's called. I think it's like an emulator for a calculator uh, in within Pearson that you can use. Excuse me. Uh, so you don't necessarily have to purchase this if you're using what's there in the online course. Also, another quick note before we dive in here is that every professor is going to do things just a little bit differently. So if your instructor has told you a specific way that they want you to do something, and I'm doing it differently, then first of all, feel free to let me know so that, I can switch tactics and be sure to explain it the way that they're explaining it. Um, but also just know that, there might be some slight differences. Also, this review is for all of the statistics courses. So there are many instructors, if we get more people coming in, they may be in a different instructor's course, and so they may have been taught things a slightly different way. But I have been told that, while we do have formulas that you guys are learning, that you are allowed to do quite a bit of it on the calculator rather than being forced to rely on doing the calculation on paper and pencil. So, all right, so here we go. Number one, how is a sample related to a population? So there's a lot of new words in this course that you're learning, and the difference between sample information and population information is a big thing. In fact, you might remember from chapter 2 that you've got completely different symbols that are being used to represent information related to a sample versus a population. Okay, so choose the correct answer below. This is, I mean, hopefully you can read this. This is already selected, right? The correct answers have already been selected on this, so you can kind of take a look ahead if I'm going too slow here. But a sample is a subset of a population, right? So we might have for a particular study, maybe the population is, every college student in the state of Florida, and a sample of that might be the college students at Daytona State College, or the college students that are, in Volusia County, or the college students that are aged 50 and up out of all of Florida, right? So it is a subset of a population. It's not the entire population, it's part of the population. And in chapter 1, they went into a lot of detail about the different types of ways that you can pull those subsets. So we're not going to dive into that too much because they don't appear to be asking too much about it, but there's a lot of different ways that you can pull those subsets. All right, so number 2 is the difference between a parameter and a statistic. So you'll notice you've probably seen this on the homework where you have lots of different ways you can answer these questions, right? So this is you have to fill in the blank for one and fill in the blank for the other. So a parameter is a numerical description of a population characteristic, and a statistic is a numerical description of a sample characteristic. Okay. Oh, there we go. It went big screen. I don't know what happened, but it works. Okay. All right. So Sean, are you there? Maybe that's why it went big screen, because Sean left. Okay, bye, Sean. But for the purposes of the recording, we're going to continue going. All right, so parameter is for population, sample is for, or statistic is for sample. So I think the book even says, here we're going to admit. All right, Sean, can you hear me again? Yes, okay, good. All right. So I was just going through talking about how population is related to, or I'm sorry, parameter is related to a population, and a statistic is related to a sample. So you can remember that because they have the same letters, right? Parameter, population, both T's, and statistic, sample. Okay, so that's a good way to remember that. Okay, number 3, determine whether the data set is a population or a sample and explain your reasoning. So some of these can be, I don't want to say confusing, but you have to keep in mind that, like the example I gave a minute ago, maybe the population is, all college students in the state of Florida. For a particular study, that might be the population. They only want to look at the college students in the state of Florida. Well, maybe there's a different study and they want to look at the college students in all of the United States of America. That's a different study, and so the population is a different group of people. You might think, oh, well, that means that the college students in the state of Florida is just a sample. But depending on the study, that could be your population. So you just have to take it question by question. All right, so for this one, determine whether the data set is a population or a sample and explain your reasoning. Okay, the number of floors in 8 buildings in a city. Okay, so 8 buildings in a city. So this is a sample because it's a collection of the number of floors for some buildings in the city. Okay, so all of the buildings in the city would be the population. I'm sorry, the number of floors in all of those buildings would be the population. The sample is just 8 of those buildings. Okay. All right. So I'm going to go on to the next question here. I'm going to go on to the next page. All right. Also, if you want me to go a little bit faster, let me know. All right. Okay, number 4, a survey of 1,500 US adults found that 58.6% have never had a vaccine reaction. Identify the population and the sample and describe the sample data set. Okay, so we're going to pull some things out of here. So we have, first of all, it's a survey, right? So they're asking people, but they only surveyed 1,500 US adults. Okay, they did not survey every single US adult, but they've told us that they're US adults. So the population would be the responses of all US adults, right? If we could get the whole population, we could get all the data available, the whole population would be the responses of every single US adult. Okay, but we just got a sample of it. We got 1,500 people that we surveyed, and so the sample is the 1,500 US adults that were surveyed. So just a sample, a portion, a part of the entire population. Okay, so then it wants us to identify, or I'm sorry, describe the sample data set. Okay, so not just this particular percentage, but all of them, right? So if 58.6% of those 1,500 people never had a vaccine reaction, well, we still got responses from the other 41.4%, and they said that they did have a vaccine reaction. So all of the people in the sample we would have to include when we are describing the sample data set, right? Not just the people who told us yes, but also the people who told us no. Or depending on the question, not just the people who told us no, but also the people who told us yes. So describing the sample data set, you've got both the percentage who did not have a reaction and the percentage who did. Okay. All right, moving on. Okay, level of measurement. Okay, so for these next few questions, we want to keep in mind what the definitions of these are. So identify the data set's level of measurement. So we've got different types of levels of measurement. We've got, see, I want to do this in order here. So we've got nominal, ordinal, interval, and ratio. Now, I read them off in that order because that's kind of a good way to think of them, sort of lowest to highest. So as you're going through and doing your review in your textbook, so I have a physical textbook. This is going to look a little bit different than your e-textbook, but it's got the same information. So I'm just going to put this up here. All right, so we have anytime that they have like these blue boxes that have definitions, if you're taking notes, which you should try and take notes in your class, make a note of those, right? You want to make sure that you've made a note of it, that you understand it, potentially that you've memorized it, right? So here we have nominal level and ordinal level, okay? So nominal is qualitative only. So we've got qualitative things and quantitative things. Quantitative like quantity, like number. Qualitative like the quality of something, like kind of just a label, right? So nominal is qualitative only. So it's categories, right? Names, labels, qualities. You can't actually calculate or computate anything at that level. All right, then we go up one level and we have ordinal. Ordinal like order. You can put it in order. So ordinal, you could have qualitative, but you could also have some quantitative things. But really all you can do is arrange it in an order or rank it, but the differences between the numbers aren't relevant. So I really liked this example that they gave here. So with the nominal, it's saying you can have numbers, but they don't mean anything in terms of, you know, kind of putting them in order. So Social Security numbers, right? So that's a label, right? And then for they have for the jerseys, same thing, right? It's just a label. All right, so now we get up to the next level here. Let's see if I can have this zoom in appropriately here. So we have interval and ratio. Okay, so you kind of move on sort of from lower to higher levels here, nominal, then ordinal, then interval, then ratio. So interval, it can be ordered, just like the last one could be ordered, but also in addition to that, you can do some calculations with it. Okay, now the difference between the interval and the ratio is that a zero entry is just a position on a scale. And again, I like the example that they used, 0 degrees. It's not a an inherent zero, right? Which they're defining inherent zero in here. It's just a position on a scale. Whereas with the ratio level, an inherent zero means that it is none, right? Like $0. Okay, so when you're writing your definitions in your notes, can also be helpful if, I don't know if you do note cards or kind of however you work it, to include things like this. Anytime they have a chart that kind of helps you visualize the information, that can be really helpful. I know I personally am a very visual learner, so stuff like this is great for me. All right, so they've got nominal, ordinal, interval, and ratio, and they're saying, can you do all these things with it? And you can see that, yeah, every single one of these, you can put the data in categories, but can you arrange it in an order, only the top three? Can you subtract the data entries? Like, does it make sense to do calculations with the data entries? Only the top two. And then can you, one way that they talk about this is it a multiple of another? Like, would it make sense to say that? And only ratio is. And then they have this great chart down here with examples, right? So if you want to find that in your ebook, spend some time looking through that so that you understand the different levels. Okay, so having looked through all that, now let's go back to the question at hand. The ages of students in a statistics class. So we can kind of, again, I'm just going to kind of pop this in and out here. The ages of students, it is ratio, right? Because we can put it in categories, we can arrange it in order, we can do calculations with it, and we can, sorry, I'm trying to see if I can put both of these on here at once. Yeah, maybe a little bit there. Sorry about that. Close this out. Okay, there we go. And you could talk about ratios of one another. Sorry, I don't know if you can hear the blinging of my computer. I'm just going to close those out as they come up. Okay, next one. Identify the data set's level of measurement. Again, okay, temperatures of 18 selected refrigerators. So something that you might want to put in your notes is that generally temperatures are not going to be at this ratio level. So we don't want to talk about like, oh, it's twice as hot out here. That's kind of more of a turn of phrase rather than, you know, sort of mathematically, we're not saying twice as hot. So if you have in your notes, if you can put that generally when we're talking about temperatures, we're not going to be at the ratio level, we're going to be at the interval level. Okay, so temperatures of 18 selected refrigerators, temperatures, we can put them in categories, we can arrange them in order, and we can do some calculations with them. All right, and then the last one here is identify the data set's level of measurement, a list of 1,287 social security numbers. So again, these are numbers, but they're really just labels, right? The numbers are just labels, which makes them nominal because that's really all you can do. Put them in categories. Okay. All right. So we're gonna to the next page here. Oh, we got one, couple more of this kind of type of question here. All right, so then we have, it's down a little bit. Identify the data set's level of measurement, the ratings of a movie ranging from poor to good to excellent. This is a great example of ordinal because, you know, so first of all, you might think, oh, nominal, because it's like categories, but ordinal because these categories can be put in order. Right, I can say I want to go, you know, the lowest rated to the highest rated. They can be put in order, so they are ordinal. All right, number 9, determine whether the data are qualitative or quantitative. So briefly mentioned this before, qualitative, qualities, quantitative, quantity like numbers. All right, the colors of automobiles on a used car lot. So colors are descriptive, right? So that is qualitative. It's not a number, it's a color. All right. Number 10, same thing, determine whether the data are qualitative or quantitative. The number of seats in a movie theater. So it's not a color, it is a number, and we can do things with those numbers. Those numbers aren't just labels. So that's what makes it quantitative. Okay. All right, number 11. Determine if the survey question is biased. If the question is biased, suggest a better wording. So one of the things that it covered in the book is briefly creating your own studies or ways to gather, you know, data. And and information. And depending on the classes that you take, you might go a bit more into this about how to create a good study. So if you have a good study, it's not going to have biased questions. All right, so this particular question is, why is drinking soda bad for you? So even without looking at the options here, we would say, okay, well, they're telling us something in the question, right? They are telling us that drinking soda is bad for you, and they're just asking us to tell them why that is. So that's what makes it biased. Okay. If what we're actually trying to get from people is something like, how do you think drinking soda affects your health? Like, do people think that drinking soda is bad for you? And we don't want to tell them that it's bad for them and ask them why. We want to ask them a sort of broader question of, how do you think it affects your health? So I feel like most of these are pretty self-explanatory and kind of self-evident here. But you know, if you ever run across any that you're a little unsure of, you know, just ask me. But I feel like a lot of these are kind of straightforward in, you know, okay, this is clearly saying it's a leading question, right? I've heard of that term. It's a leading question. Why is drinking soda bad for you? It's a leading question, which means it's biased. Okay. Number 12, same type of thing. Determine if the survey question is biased. If it's biased, suggest a better wording. How much do you sleep per night during an average month? Okay, so it's not saying, you know, you don't sleep at all. How little do you sleep? Just how much do you sleep? So it's not leading the respondent to any particular answer. Okay. So, and if you look at some of the other things here, it can often give you a little bit of insight, kind of additional information. So we know that this is the right answer, and this is the wrong answer, but it's talking about, if the question was, why is sleeping 8 hours per night good for you? That would have been a biased question, in the same way that, why is drinking soda bad for you? This question is biased because it's telling you something. It's saying, hey, sleeping 8 hours per night is good for you. Now tell me why, right? That's biased. That's leading. That's why that's not the right answer. This one's the right answer. Okay. All right. Now we're getting into some calculations. Might try and pick up the pace a little bit. I want to see how much we can cover, and we've only got about 30 minutes left. Okay, so now we're getting into frequency distributions. Okay, so lots of things happening here, and lots of ways we can use the calculator to deal with some of these. Okay, so it's asking us to find a few things. Use the given frequency distribution, which is what this is, to find class width, class midpoint of the first class, and class boundaries of the first class. Okay, so the class width. A lot of people get confused and they think that the class width goes from here to here. It does not. Your class width goes from your lower class boundary to your next lower class boundary, right? It goes from here to here. Or you can think of it as, it goes from your upper class boundary to, I'm sorry, I just said boundaries. I meant limits. I apologize. Rewind. Lower class limit to lower class limit. Boundary is something different. Sorry, I was looking at the boundary. Boundary is different. This number right here is, excuse me, is your lower class limit. This is the next lower class limit. This is the next lower class limit. So your lower class limits are over here. Your upper class limits are over here. So your class width goes from your lower class limit to your next lower class limit. Or you can think of it as going from your upper class limit to your next upper class limit. So you would take the difference between these. So you would say, okay, well, how do I get from 135 to 140? You can, if they're weird numbers, feel free to plug it into the calculator. But here we would add 5, right? Add 5 to get from here to here. Okay, so that's how we're getting a class width of 5. Okay, then it wants the midpoint. Now, in this particular question, it just wants you to find the midpoint of the first class, but often you're going to need to find the midpoint of all of the classes, either because it's asking you for it or because you're going to need it in order to calculate some things later on. Okay, so how do we find the midpoint of a class? We find you're essentially doing like the average of these two. And what I mean by that is you add them up and divide by 2. So if we were to do it with paper and pencil, we would do 135 plus 139 divided by 2. But we're probably not doing it on paper and pencil. We're probably doing it on the calculator. So let's talk about some important things to keep in mind when we're doing things on the calculator. Hold on, can you see? There we go. Now we can see the question in the calculator. All right, so order of operations is important, okay? This, when you put it into the calculator, there's a couple of ways to do it. You can start by adding these together and then hitting enter and then dividing by 2, right? 135 plus 139, and then I hit enter and then I divide by 2, right? That gives me 137, which is what our class midpoint is, 137, okay? But if I wanted to do it all at once, you have to make sure that this thing, this whole thing that's being divided by 2 is in parentheses, okay? So you'll use the parenthesis. Can you even see that? Hold on. We've got the parenthesis button right here. We do parenthesis 135 plus 139, close parenthesis. Then we can divide by 2. And that's how we're going to get the 137. So a mistake that I often see people make is that instead of having the numerator of this fraction, the whole thing be in parentheses, sometimes they'll write it as 135 plus 139 divided by 2, like they'll plug it into the calculator like that. If you do that, order of operations tells the calculator to do this division first before that, and that's not what we want to have happen, right? So incorrectly would be saying 135 plus 139 divided by 2, you'll notice we're getting a completely different number. So just be very careful with that. If you're unsure about how to use the parentheses, then don't do it all at once. Do it one step at a time. 135 plus 139, enter, then divided by 2. And that's how you'll get your 137. So what was the 137 again? It was the midpoint, right? The midpoint of this class. So, which makes sense, right? It's the number directly in between the, excuse me, the lower class limit and the upper class limit. 137 is directly in between 135 and 139. Okay, so that's 137 is our class midpoint. Now they want the class boundaries. So, like I said earlier, the class excuse me, the class limit is different than the class boundary. The class limit are the numbers that are here. The boundary is what's in between here and here. So we often use these when we're doing a graphical representation of the data, which I'm sure there's a question in here about that too. So we're going to see it, visually, but it's the number between 139 and 140. Right, so the number between these two, or the number between these two, okay? So similar to how we got the midpoint, we're going to add these up and we're going to divide by 2 in order to get the number in between them, right? So we're going to go 139 plus 140, enter, and then divide by 2, and we have 139.5. Which again, we can kind of look at this and say, well, hey, does my answer make sense? Yeah, that makes sense because it's the number in between 135 and 140, right? So we have, you'll notice here that none of the numbers would overlap, right? I don't have something that would be in this class that would also be in this class, right? That's how they're kept separate. Okay, so 139.5 is the number in between those. And they want the boundaries plural of the first class. So we're looking at the number over here is 139.5. So that's going to help us to determine what the number over here is. Because with these classes, we're going by integers, right? So we have 139 and then the next sort of counting number is 140. You're not always going to have that. As you go farther in the class, you might have decimals here. So you need to know, how far do I go to get the number that's in between here and here? That's going to tell me how far I should go in this direction to get the number here. So from 139 to 139.5, that was a change of 0.5. So if we went, and I'm going to kind of write these down here. Right? The boundaries are the numbers on either side of the class limits. So we went 0.5 in this direction, we're also going to go 0.5 in that direction, right? If I wanted to do, let's say they said the class boundaries of the last class, we would go 0.5 in this direction, 159.5, and we would go 0.5 in that direction. So 155, and then to the left of that, or 0.5 less than that, is 154.5. What you're going to notice is this number is going to be the same as this number, right? So like if I were to fill all of these in, that might be helpful. Let's do that. Let's fill all of these in. This number is the same as this number. So earlier when we were talking about the class, excuse me, class limits, there is no overlap. With the boundaries, this number is the same as this number. They're the same number. Okay, so if you want, you can do kind of one side, and then that can help you determine the other side, right? So 0.5 more than that, 149.5, which means this is also 149.5 because this number is the same as this number, right? These are the class limits. These are the class boundaries. Okay. All right, so we went 0.5 in this direction. Now we're going to go 0.5 in that direction. So 135 minus 0.5 is 134.5. So that's how they're getting 134.5 up to 139.5. Okay. All right. Okay. Tell you what, for the purposes of time, I'm going to jump around a little bit. I'm going to jump to showing you how to do some stuff on the calculator. These are really good questions, but we're going to jump around. Let's see. Okay, so this is good. Okay, determine whether the statement is true or false. The difference between two consecutive midpoints is equal to the class width. So I'm actually going to jump down to number 16 and use this as an example. This is not this question, but I'm going to use it to talk about the frequency here. So, excuse me, this is showing some temperatures and their frequencies. So let's use it to talk about this. The difference between two consecutive midpoints. So real quick, let's calculate what the midpoint is. So we're going to add these together and divide by 2, and that's going to give us 41. We're going to add these together and divide by 2. That's going to give us 44. Okay, so you know how we were talking earlier about, excuse me, the class width is from the lower class limit to the lower class limit, or it can be from an upper class limit to an upper class limit, right? So to get from here to here, I would add 3. To get from here to here, I can add 3. You can do the same thing with the midpoints. Once you find one of the midpoints, you can add the class width to get to the next midpoint. Okay? So that's what it's talking about here. The difference between two consecutive midpoints, right? These are consecutive, one after each other, is the class width. Yes, that's true. The midpoint is the sum of the lower class limit and upper class limits divided by 2, right? 40 plus 42 divided by 2, that's 41, that's the midpoint. And the distance between the two consecutive lower or upper class limits is equal to the class width. So it can be lower class to lower class, upper class to upper class, or midpoint to midpoint. All of those things are the class width. Okay, which, since we're using this as an example, we've already answered some of this next question. Use the frequency distribution to find the class width. Okay, we found the class width, right? It's 3. And here I'm going to kind of, because we're answering this. I'm gonna go like this. We're gonna see some of this. I'm not sure how much of this I can show all at once here, but all right. So, all right, so we have that it is 3. All right, the class midpoints. So you can do these however you find it easiest. I like to find the first midpoint and then just add the class width after that to go after that. So that's what they did here, right? They said +3 plus, well, actually, I don't know how they did it. They could do it however they want. But if we're looking at the answers here, they just did +3, +3, +3, +3, +3 to get all of the midpoints. Okay, then they want the class boundaries. So we're going to do the same thing that we did on the last one. We're going to say, we're going to add these two together and divide by 2. That's going to get 42.5 is the upper boundary for this, which means it is also the lower boundary for this next class. Okay, now that we have that, now we know how much we're supposed to go in either direction. So we're going 0.5 in each direction. So 0.5 in this direction is going to be 39.5. Okay, so we continue doing that all the way down, and that's how they're getting, I'm going to move this up a little bit. That's how they're getting all of the boundaries here, right? So we have the 39.5 is the lower boundary of the first class. The 42.5 is the upper boundary of the first class, and it is also the lower boundary of the second class. Because remember, with the boundaries, it's the same number here and here, here and here, here and here. Whereas with the limits, there is no repetition. This is a different number than this. Okay. All right. Okay. Let's see if we can go a little faster. I think I spent too long at the beginning just chatting. Get more done. Okay. Use the frequency distribution to construct an expanded frequency distribution. Okay, so they're having us do some additional things. So we've already talked about the midpoint. We're not going to go through that again. The next thing is the relative frequency. Okay, so the relative frequency, in order to figure that out, so you'll notice these are all decimals, right? It's like a percentage, okay, but in decimal form. We need to find the sum of all of the frequencies. Now, depending on how they give you the data, you might already have that, but if they gave it to you like this, you have to find the sum, right, capital sigma here, sum, of the frequencies. You have to add them all together, okay? You can add them together here or add them together here, but you're going to add all of them together. So let's go ahead and actually do that. So we're going to do 17 plus 44 plus 68 plus 69 plus 77 plus 68 plus 22, 365. Okay, now that was one way to find the sum. We're going to look at another way, excuse me, in just a minute when we do some other calculations. But if that's all you're doing, okay, so we have 365. So the sum of the frequencies, this is your sample size, your lowercase n. Okay, that's how many data points we have. Okay, we have 365. Out of those 365, 17 of them fell into that class. So we're going to do 17 over 365, and that's what's going to give us that 0.05. Right, 17 over 365, 0.05. Now we're rounding, right? Yeah, round to the nearest hundredth as needed. Okay, so we have 0.046 is going to round up to 0.05. Okay. All right, so let's do one more of those, and then we'll talk about the cumulative frequency. Hold on just a moment here. Okay, sorry about that. Okay, so same thing here. We have 44 of the temperatures fell into this class. Okay, so we're going to do 44 part over the whole, right? The percentage, the part over the whole. 44 were in that class. and the total number that we had was 365. So we get 0.12. So that's how they're getting 0.12. You continue that for all of these. All right, cumulative frequency. So remember, all the cumulative frequency is that you're saying everything that's happened up until that point, frequency-wise. So with your first is just, well, what's the frequency? 17. Now, with the next one, we say, okay, well, we're talking about this and everything that happened before it. So we're adding these together. So we're saying 17 plus 44. Well, that's 61. Okay, great. Then the cumulative frequency of the next is everything that happened before. So what you can do is, instead of doing, okay, 68 plus 44 plus 17, you just take your last cumulative frequency and add your next frequency of the next class. So we already have 61 in the calculator. We're just going to do plus 68 to get the 129. And then we're going to do plus 69. Whoops. It helps if you type it in correctly. 129 plus 69. There we go. Now we have 198. And then plus the 77. And now we have 275. And then plus the 68. And we have 343. You get the idea. Okay. All right, so again, this is kind of an interpreting it. I'm going to jump ahead to some of the calculation ones that we need to do. Real quick, I'm going to go through this one. So talking about skewed, right? So some people get confused with the skew. If you have a graph that generally looks like that, the skew is where the tail is, not where the big part is, but where the tail is. Think of it kind of like an arrow. It's pointing to the left. This is skewed left. Whereas if you have a distribution that looks kind of like that, that is skewed to the right because that's where the tail is. The tail is over on the right. Okay. Symmetric just means that if you were to put a line in the middle, it looks kind of a mirror image on either side. Uniform is where it's like a big rectangle. It's all the same. Uniform is also symmetric, but symmetric, you can have all sorts of things that are symmetric. So symmetric could be a bell curve. Symmetric could be uniform. You could have something that maybe goes like that, right? Or, all sorts of things. Okay. Okay, here we go. So now we're getting to some more things to plug into the calculator. All right, approximate the mean of the grouped data, round to the nearest whole number. So first of all, why are we approximating? Why can't we just get what it actually is? Why do we have to approximate it? Well, because we don't have the original data set, right? What we have is a frequency of each of these classes. We know that there were 9, well, we don't know what this is, but 9 things that fell into this weight category. Okay, maybe these are, I don't know, animals or something. So there were 9 animals that weighed this much, but we don't know specifically how much they weighed. So we would get a more accurate value of the mean if we had the original data, but we can at least estimate or approximate the mean given this. So what we're going to do is, the first thing that we need to do is we need to find the midpoint. And you can kind of write it wherever you want. I'm going to write it over here, actually. Excuse me. We're going to find the midpoint of each of these, because the midpoint and the frequency is what we're going to plug into the calculator. Okay. So kind of looking ahead here, our list 1 is going to be our midpoint, and our list 2 is going to be our frequency. That's what we're plugging into the calculator. So we don't know what the values specifically of these 9 were. So we're going to just go ahead and assign all of them as whatever the midpoint of this section is. So again, the midpoint we have, plugging it in, we go 135 plus 139, and we divide that by 2, and we get 137. Okay, so that's the midpoint. Now we can do the same thing here, or we can say, oh, well, to get the next midpoint, I just need to add my class width, right? Class width. So what's class width? It's where we go from 135 to 140, so we're adding 5. So we're going to do the same thing here. We're going to go plus 5. So I have 137, I'm going to say plus 5, enter. That gives me 142. I'm going to say plus 5 again. That gives me 147. And I'm checking as I go, right? Because maybe I typed something in wrong, right? Earlier I had Butterfingers and I typed something in wrong. So you want to be kind of being aware of, does my answer make sense as you go through, right? This is a tool, but it's not the end all be all. We still got to use our brains while we're using the tool. Okay, so yeah, it makes sense. 142 is between 140 and 144. Now, another cool thing on the calculator, I've started creating a pattern here. I've told the calculator twice in a row that I want to add 5. So if I just hit the enter without hitting add 5, it's going to say, oh, do you want to add 5 again? And I hit enter again, and oh, do you want to add 5 again? And it's just going to keep doing the same thing. I have to establish that pattern by, sorry, I'm trying not to cough directly into the microphone here. You have to establish the pattern by adding 5 a couple of times, but once you've added 5 a couple of times, or whatever the calculation is that you're doing, if you want to keep doing it, you can just hit enter rather than continuing to type in plus 5. All right, so that's giving us our numbers. We have 152 and we have 157. Again, do those make sense? Yes, 152 makes sense as the midpoint here. 157 does make sense as the midpoint here. Okay, great. Now let's plug these in where we're going to do some calculations. Okay, so we're going to go to statistics, and we are going to edit some lists. So edit is the first thing, so we can just hit enter. So we've got a bunch of lists here. If you have numbers in your list, you're going to want to clear them. Okay, so you're going to hit the up arrow to go to where you're actually highlighting the list, and you're going to say, hey, can you please clear the whole list? You're going to hit clear, and then you're going to hit enter. Now, I don't have anything in this list, so I don't need to. But that's how you could clear the whole list if you needed to. Okay, so we're going to put list 1 is going to be comprised of our midpoints. List 2 is going to be the corresponding frequencies of those midpoints. So we have 137, and then I hit enter, 142, 147, 152, and 157. I'm going to arrow to the right to get into list 2, and I'm going to put in my frequencies here. All right, so I've got 9, 7, 20, 17, and 10. Okay, great. So I've got my midpoints, I've got my frequency. Now I want the calculator to do some stuff with this, right? I want it to calculate some things. So we're going to go to stat, and instead of editing, we're going to go calculate. Now, right now, we're doing one var stats. Later on, you'll do some of these other things, but for right now, we're doing one var stats. We're going to hit enter, and we're going to tell it what to look at. We're going to tell it that the list of the data itself, in our case, the midpoints, was list 1. That's already there. And if you have a frequency, which we do in this case, we're going to tell it where the frequency exists. The frequency exists in list 2, L2. So I'm not sure if you can see the whole thing here. So down here, no, you can't see that. Let me move that a little bit more. So L2 is directly above the 2. So if we want to do that, we have to hit the second. There we go, the second button, kind of like shift, right? So we go second, L2, and it displays L2. And then we're going to hit calculate. Now, real quick, a note. If you didn't have frequency and you just had the original data set, just a whole list of numbers, you would want, where it says frequency list, you would want to clear that. You wouldn't want it to have anything there. You just want L1 to be all of your data. But in our case, we do have frequency. So we need to have list 1 is the midpoint of those classes. List 2 is the frequency of the corresponding class. All right, now we're going to hit enter and we're going to calculate, and it spits us out a bunch of information. All right, so this is where we want to make sure that we're comfortable with the different symbols for population versus sample. Excuse me. All right, so mean of the grouped data. So mean is this symbol right here. We call it X bar, right? This is the sample mean. Now in the calculator, we have 147.952381. they want us to round to the nearest whole number. So rounded, that is 148. You'll notice that it also gives us a bunch of other information, which we can use later on. Okay, so let's get to some of those questions where we're going to use that. Okay, so again, we're talking about kind of the shape, right? So this is skewed to the right because the tail is over on the right. Here we go. Okay. All right, so I'm going to use the calculator to find some of these numbers. Number of credits being taken by a sample of 13 full-time college students. So it's a sample and there's 13 are listed below. Find mean, median, mode, if possible, and if any measure cannot be found or does not represent the center of the data, explain why. All right, so first thing we're going to do is, I just hit clear real quick. We're going to go back and we're going to put all of these numbers into our list one so that it can calculate that for us. So I'm going to hit stat, and then edit. I'm going to clear this list. Again, I'm going to arrow up to L2. I'm going to hit clear and then enter. That's how it'll clear it. I'm going to go back to the top of L1, clear, and then enter. And then I'm going to type in these numbers. Let's make sure I type them in correctly here. Okay, now something that can be really useful is to have the calculator order the numbers for you in either ascending or descending order. So let's do that real quick. So what you're going to do, excuse me, is you're going to go to stat once you've put the numbers in, and you'll notice instead of 1, if we look down at 2 and 3, we've got sort ascending and sort descending. Okay, so let's go to number 2, sort ascending. And it says, okay, well, what do you want me to sort? We want it to sort list 1. And so we're going to tell it L1. So we're going to hit second, and then the number, you can't see this, the number 1, because L1 is directly above that. And then I always like to make sure that I've closed my parentheses and hit enter. And the calculator tells you, okay, I did that. I finished the task. So now we're going to go and we're going to take a look at what the calculator did. We're going to go back to stat, and we're going to go back to edit because we're going to look at the list. And now we can see that it has put it in order, right? All the 7s are first, then the 8s, then the 9s, then the 10s and the 11s. All right, so that's in order. So that's a really useful thing to have the calculator do. All right, so they want us to find some things here. Also, first of all, N, that is your sample, excuse me, number of items in the sample. Okay, first thing is the mean. So we're going to go to stat, we are going to calculate one variable stats, and then this did not have a frequency, so we need to clear that. We're just going to have it look at the sample data itself that was in list 1, and now we hit enter and enter. Okay, so the sample mean is 8.23 blah 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 blah. They wanted us to round, they're going to tell you where to round. Here we go. Rounded to 1 decimal place as needed. So always be sure that you're looking at where it's telling you to round. I know we've gone over on time here, so if you need to leave, that's fine. I just really want to try and get through some of these calculator examples before I log off here. Okay, so the mean is 8.2. Okay, now got a bunch of other things happening here, right? So we have the N, sample size is 13. The minimum value is 7, and then it gives us the first quartile, the median, the third quartile, and the maximum. So if you needed to find the range of the data, you would do the maximum minus the minimum, right? So 11 minus 7, okay? They're not asking us for that here, but this is where you find those numbers, or you can, I mean, depending on how big your data set is, you know, you can sometimes, it might even be easier to just look at the numbers on the paper rather than typing them in, depending on, you know, if they're asking you for just that, might take more time to plug them in. Okay, so the mean is 8.2. It's asking, does the mean represent the center of the data? So if we look at the numbers that we have here, let's go back to the list. So we've got a bunch of 7s, we've got some 8s, we've got a 9, a 10, and a couple of 11s. So the mean of 8.2, yeah, that represents the center. It's not like we have, because they've talked about outliers, right? It's not like we have a bunch of outliers that are pulling our mean, right? Because mean is affected most by outliers, as opposed to median, right? The mean is really pulled by outliers. We don't really have outliers here. So yes, the mean represents the center. Okay, then they want, we're just going to kind of move this here, the median. So the median, I can do second mode to quit, right? Second quit, and it gets me back kind of to the home page. Or I can say, no, please go back, calculate these things, and I can tell it to calculate again. Okay, so I'm looking back at my numbers here. The median. So the median is your second quartile also. Don't forget that, right? First, second, and third quartile. The median is the second quartile. This is something to keep in mind. But it's telling us that the median is 8. Well, hey, that's cool. 8 is pretty close to 8.2. So the mean and the median are pretty close to each other. So the median is 8. And does the median represent the center of the data? Yeah. Yeah, that's pretty close to the 8.2. So that makes sense. All right, so then it says the mode. So remember, mode is the data value that occurs most often, right? So we can either look back at the paper or we can look in the calculator. I'm just going to pull the paper up here. We look back at this list. How many times did 7 occur? 1, 2, 3, 4, 5, 6. It occurred 6 times. Now we do have some other repeats, right? We have 8 occurred 3 times and 11 occurred twice, but 7 occurred the most often. So that's the mode because it occurred the most often. You can be bimodal, right? If you have another number that occurs the exact same number of times, like maybe you had 2 different numbers that both occurred 6 times, you could be bimodal. In this case, we just have one mode, it is 7. So, excuse me. So the mode is 7. But does it represent the center of the data? So it doesn't, because it is literally the smallest data value that we have, okay? Just because it occurs a lot doesn't mean that it is the center of the data. It's the smallest number in our data set. It is not the center. Okay. Right. And okay, let's see what else. All right, approximate the mean. So again, this is one where we would plug this in, excuse me, to our, I'm just going to kind of fly through this. I know you're good to keep going, but I don't want to make this go too much longer. All right, so we've got, we're going to put our midpoint in list 1, right? List 1 is the midpoint. And we've got list 2 is going to be our frequency. I could spell that out, but I'm just going to write frequency. So again, I'm going to clear this and I'm going to type in the midpoint. So real quick, what do we think the midpoint is going to be here? So we're going to do 30 plus 35, and then we're going to divide by 2, right? 32.5. So midpoint of 32.5. I can get to my next midpoint by doing the same calculation here and here and here, or I can say, well, I can just add my class width. So 30 to 36 is 6, right? We're adding 6 every time. So that means we have a class width of 6, so we can do the same. We can add the class width to the midpoint to get the next midpoint. So that's 38.5, oops, plus 6. 44.5, again, kind of checking, does that make sense? Yes, it does. 50.5, oh my goodness. All right, so we have our midpoints. The L2 is the frequency, that's these numbers right here. So we're just gonna go and plug this in real quick. So list 1 is our midpoints, list 2 is the corresponding frequencies of those classes. And then we are going to have it calculate. So we're going to go stat, calc, one variable stats. Now we need to update this, right? Because we need to tell it, hey, I do have a frequency, right? I've got midpoints in one list and I've got frequency in the other. Where was the frequency located? We go second 2 to tell it L2, enter, enter. And it gives us a bunch of information. The mean of the frequency distribution. Oop, I typed something in wrong. Let me go back and see what I did here. 32.5, 38.5, 44.5. Oh, yep. See what I did there? I typed in 40.5 instead of 50.5. All right, so now, oops, calculate. List 1, list 2, calculate. There we go, that's better. 38.1. All right, so great example of go slow, check your work, right? So again, this is a tool, but it's only as powerful as a person using it, right? So I don't know if you've heard the phrase garbage in, garbage out, right? So if I put in garbage numbers, I'm going to get garbage answers. So go slow, double check your work. Okay. All right, so then we have, let's see. Okay, so this is just kind of asking you to create that frequency. I do want to go through that real quick because I think creating the classes, sometimes people forget you know, how that goes. So creating it from scratch, when you have the raw data and then you're creating it, first of all, it's really helpful to stick all of these numbers inside a list and then sort the list, right? So that's something that's helpful. But I want to real quick do the calculation for how to determine what your class uh, um, sorry, not class boundaries are. Excuse me. So what you're going to do is, so step 1, and somewhere in the book it has this kind of step by step, but you're going to decide on the number of classes. Here, it specifically tells you that they want you to use 5 classes, okay? You're going to find the class width. That's the first thing that you have to do. So in order to find the class width, so I guess I'll just write it out here. Class width. This pencil really wants to keep breaking. The class width is your range over the number of classes. And then I like to do a little arrow and say go up one. Okay, so what does that actually mean? Let's do this. So the range is the highest number, right? Your maximum minus your lowest number. So if we were to plug this into the calculator and put it in order and have the calculator sort it, we would get that. But for right now, I'm just going to look and see if I can kind of quickly identify what is the highest number. So I'm seeing a 262, no, 287, right? So it looks like is 287 the highest number? Yeah, it looks like 287. Right? And the lowest number, what's my lowest number? Let's see, 127, is that the lowest number I see here? Yeah, I think that's the lowest number. Okay, that's going to be my range, highest to lowest. And then the number of classes. Tell you what, hang on just one second, everybody. I say everybody, it's just you, Sean. Hang on. All right, thanks for your patience. Okay, so we've got our range here. We're going to divide by the number of classes that we want. Now, keep in mind, here they told us to use 5 classes, but if they don't specify the number of classes, if you get to decide the number of classes, you always want your classes to be between like 5 and 20. You don't want any less than 5 classes and you don't want any more than 20 classes because then it can be kind of difficult to see what's going on. So, all right, so we're going to divide by the 5 classes that that we want to have. All right, so we're going to go 287 minus 127. We're going to take that and we're going to divide by 5. Okay, so that's 32. But I don't want my class width to be 32. I need to go up one more. So my class width is actually going to be 33. Okay, this part is really important. If you forget to go up one, it's going to cause problems because you're not going to have enough, like you're not going to be able to fit all of the data into the classes that you're creating. You're going to be off. Okay, so don't forget to go up one if you yourself are creating the classes. All right, so to create it, we start with, and we're just going to kind of recreate this that I mean, they already have the answer there. We're just showing how we get this. Wow, my pencil just keeps wanting to break. All right, so to start off, we're going to start with the lowest number, our minimum value. That's 127. Okay, we're going to go from our lower class limit to our next lower class limit by adding the class width that we just found, right? This is our class width. So we're going to say plus 33 to get our next lower class limit. Sorry, this is angled here. So, if you want, you can plug it into the calculator. It's always good to, try and do mental math, but then always, you can check yourself on the calculator. So that's going to be 160. Now I can keep going, or I can pause here and I can say, well, what's going to be my upper class limit? Well, it's just going to be one less, right? 160 minus 1 is 159. It's one less because we're dealing with integers here. Once you get into decimals, having decimals in your classes, that's going to be a little bit different, but that's an easy way to think of it now. All right, we're going to continue to add our class width to get the next lower class limit. All right, so 160 plus 33 is 193. Right, and then we can add 33. Now that we have this one, we can also add 33 over here, right? 159 plus 33, that's going to give me 192. Or we can say, well, what's one less than this? And then that's what goes there. So that's how we're going to create classes. Then what we're going to do is, after we've created this, or we're going to pretend like we created this whole thing, we're going to go through and we're going to tally them up, right? So you have a column for a frequency tally, and then later we will turn it into the nice pretty one where it's just a number. But for right now, we have a tally. So 193 to 225, I'm just kind of flying through this. Minus 258, 259 to 291. Okay, so 168. So we're going to say, okay, well, where does that fall? And we're going to place a tally mark. 168 falls in this class, so we put a tally mark here. 160, where does that fall? It's also here. 127, that's here. 127, that's here. 182, that's here. 163, that's also here. We got a lot in this class. 168, that's here. Okay, 220, so that's down here. 145, that's here. 134, that's here. 196, that's here. 210, here. 155, here. 257, that's here. So on and so forth. You're going to create all of your tallies, and then you're going to say, okay, well, how many were actually in each one? That's the actual frequency. Okay, so you might have to create the frequency distribution yourself, or they might give you the frequency distribution and you have to do stuff with it. So make sure that you're comfortable creating it yourself, and don't forget that you have to go up one when you do your range divided by the number of classes that you want. Okay, all right, let's keep going. Let's see if we can get through all of these calculations. All right. Okay, so the histogram, creating a frequency histogram, there's a couple of different ways that you can display it. So the numbers on the bottom can either be your class boundaries, or they can be the class midpoints, right? So the number in the middle of this block here can be your class midpoint, or you can label the edges of the block as your boundary. Okay, not limit, but boundary. So you can do it either way. Okay, this one's asking you to, create it and then talk about the shape of it. So this one, again, we're talking about skewing. It's kind of shaped like that, right? It's kind of shaped generally. See that? Like that. It's skewed. The tail goes to the right. So it is positively skewed, right? Positive is over here. If it was negatively skewed, it would be the tail over here to the left. That's negatively skewed. Oops, sorry, couldn't see that. Okay. All right, so, okay. I'm trying to decide if we should we kind of already did this one. Okay, so yeah, this one is talking about kind of how it gets pulled. And I did touch on this briefly before. So when you have a number that is an outlier, it is going to pull the mean more than it's going to pull the median. Okay, so in this question, it's saying, I mean, not that this is necessarily an outlier, but during a quality assurance check, the actual contents in grams of 6 containers of protein powder were recorded as, and it gives a bunch of numbers, find the mean and the median. Then it says, hey, actually the third value, this value was incorrectly recorded, or incorrectly measured, and it's actually a completely different number. Instead of 1503, it's actually 1518. Find the mean and the median of the contents again with the actual real numbers. Which measure of central tendency, the mean or the median, was affected more by the data entry error? So, I mean, again, we're just kind of fly through this. We're not going to create this. We would plug those numbers in to our L1, and then we would have it calculate stat calc 1var stats. It's going to give us the mean. Remember the median, it does say MED for median, but that's also your second quartile. Always keep that in mind. But what's happening is, so so the mean, the median, and then we correct the error, we get the new mean and the new median. So with the error, the mean is 1519. Once we correct the error, the mean increases to 1522. So it went up 2.5. Okay, it increased by 2.5 because it went from 1519 to 1522. Okay, the median, it was 1521 before the error. Now it's 1522. It also increased, which makes sense because this went from a small number, 1503, to a bigger number, 1518. But it only increased by 1, right? So the mean was affected more. It was increased by 2.5, whereas the median was only increased by 1. Okay. Find the range. So remember the range. Range is your max minus your min. You can, it might be easier for you to just kind of visually see what's my biggest number, what's my smallest number, and subtract them. Or if you're also going to do other things with the numbers, it can be helpful to plug it into your list by going to Stat, Edit, plug the numbers into your L1. Then you go back to Stat and you say, hey, can you sort what's in my L1? It says it does it, and then you can go back and look at it by going into Edit. Okay, so don't forget that that's how you do that. Okay, sample standard deviation. So now we are talking about these things. Okay, so we're going to plug these numbers in. Right, we're going to do 22, 29, 21, 24, 27, 28, 25, and 36. Real quick, let's go back to the book, and I want to show you a great chart that is super helpful that you want to make sure that you have memorized. Let me get the right page here. second. So what I am pulling up here is the chart that shows what the symbols are for sample versus population um, for things like your standard deviation and your mean and your variance, because those are different symbols. Right? And you want to make sure that when you're looking at your calculator or whatever other technology that you're using, that you're looking at the correct number, because the sample mean is different. Where is this chart? I thought I had it doggy-eared. Apologize for the delay here. I went too far. Okay. So I'm not finding it, but it is in there. I might look again, but I don't want to waste too much more time. That's okay. So we are going to have it calculate. So we're going to go to stat. We're going to go to calculate. We're going to go to one variable stats. We're going to say, no, I don't have a frequency list this time. I just have a set of data here, and we're going to have it calculate. Okay. So we have sample. My poor pencil keeps breaking. And we have population. We need to know what the different symbols are for each of these, right? I don't know that I needed that many. So we have, whoops, mean. So the sample mean is X bar. The population mean is this little symbol, which is called mu. Mu, like a cat, mu. Then we have standard deviation. Right? So in your calculator, the S sub X is your sample standard deviation, and your sigma X is your population standard deviation in the calculator. Okay, so if we're looking at the calculator, it's given us a bunch of things. I need to make sure that I am looking at my sample. I said sample standard deviation. I need to make sure that I'm looking at my sample standard deviation of 4.7509, blah, 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 blah. So they said to round to the nearest 10th. So rounded to the nearest 10th is going to give me 4.8. If I accidentally looked at the population standard deviation, I'd get the wrong number. I'd get 4.4, which isn't even an option here, right? So you do need to be careful that you're looking at the right symbols. So I'm sorry, I don't know what page on the ebook that chart is, but somewhere in your ebook, it does have a little chart where it reminds you of, hey, here's what your sample symbols are, here's what your population symbols are. Okay. All right. We're getting there. We're almost done. Okay, empirical rule. Let's talk about this. Okay, the empirical rule says that if you have a general bell curve shape to your data, okay, that you've got your mean in the middle, okay, if you go one standard deviation in each direction, that's going to give you, what is it, 68. 68% of the data is within one standard deviation. If you go out another standard deviation in each direction from your mean, that's going to give you 95% of the data. And finally, if you go out a full 3 standard deviations in each direction, that's going to give you 99.7% of your data is going to fall within those standard deviations. Okay, so now it's having us think about that, but with actual numbers, right? So we have, let's do some numbers here. We have the mean length of a human pregnancy is 270 days. So that's this right here, 270. A standard deviation is 11, okay? So if we go plus 11 and minus 11, that's going to give us, we can, again, you can always just plug it into your calculator, right? 281 to the right, and then 259 to the left. Okay, so that's one standard deviation above and below. Use the empirical rule to determine the percentage of women whose pregnancies are between 259 and 281 days. Assume the data has a bell-shaped distribution. If it has a bell-shaped distribution, that's why we're allowed to use the empirical rule. If it's not bell-shaped, then the empirical rule is not going to be applied. So it's one standard deviation in each direction, and the empirical rule says that if we go in one standard deviation in each direction, 68% of the data falls within those two numbers. So that's why it's 68%. Okay. All right. So this is having you approximate the sampled standard deviation. So again, remember the symbol for the sampled standard deviation versus the population standard deviation. That's sample, it's population in the calculator. We can't just plug in 50, 52 into list one. Into list one, we have to have the midpoint, right? Don't forget what actually gets plugged in. List one is the midpoint, list two is the frequency. Plug that into your two lists and then have it calculate, right? Stat, calc, one variable stats. Make sure that you have list one in list. Make sure that you do have list two in frequency if you are pulling from a frequency distribution. Like I said, I'm kind of flying through here because we are 30 minutes over. Just really wanted to get to some of these problems at the end so that you can see how to do it on the calculator. Okay, range, mean, variance, standard deviation of the sample data set. So let's run through this one real quick. All right, stat, edit. I'm going to clear my list. I'm going to go up to L1, hit clear and enter. Plug in my numbers. 12, 19, 23, 14, 20, 16, 20, 18, 14, 16. Okay, so we're going to go stat, calc, one variable stats. I don't have a frequency list here. I just have the raw data. So I'm going to clear that and then I'm going to calculate. Okay, it gives me a bunch of information and we have to find all of this. Now, the range, remember, is your max minus your min. Okay, conveniently, it tells us what our max and our min is. The max is 23 and the min is 12. And what's 23 minus 12? 11. So again, if that's all they were asking for, it might have been faster to just look at this and say, that's the biggest number and that's the smallest number. But because they're also having us do other things, we might as well just plug it in. Okay, the mean. So remember, this is a sample. So the sample mean is your X bar. That's 17.2, right? So that's where they're getting that. Okay, the variance. So variance is 11.5, right? So where are they getting that from, right? How do we get the variance? We take our standard deviation and we square it, right? Which standard deviation are we taking? The S or the sigma, the lowercase sigma? This is a sample, so we have to do S sub X. So this 3 point, and I'm actually going to write it down because we don't want to be rounding, right? 3.39280284. Oh, that's something I don't think we talked about yet. When you're calculating, you don't round until the very end, right? So if you have multiple steps in your problem, don't round at every step, round at the very end. Technically, we're already rounding here, but this is just kind of to get the answer faster because we're not going to, excuse me, use the formula. Now there is a formula, right? The formula is in the book and you want to be aware of the formula. Depending on your teacher, they might ask you to like kind of show them step by step that you can work through the formula. But a lot of the professors are, we want you to know there's a formula, but really you're just going to use the calculator to have it do the formula for you. But you still need to be aware of like what the things represent, right? So variance is the square of the standard deviation. So we're going to take, didn't mean to hit the arrow, but that's fine. We're going to take this 3.39280.284, and we're going to square it, right? This little, can you see where I'm hitting? No, you can't. This little x2, right? With a superscript x squared. We're going to square it. Then we hit enter and we get 11.51111111, rounding to the nearest tenth. That's how they're getting 11.5, right? Because it is the sample standard deviation squared is your variance, okay? And then we go back and we say, show me the stuff again. Standard deviation rounded to the nearest tenth, that's the 3.4, right? Okay. Okay, let's see. Okay, z-scores, yes. Let's talk about z-scores. Okay, so what is your formula for your z-scores? It is your data value minus the mean over the standard deviation. X minus the mean over the standard deviation, if you've got the sample, or if you've got the population, then you're looking at the other symbols, right? Okay, so real quick, pop over to the, I really wanted to find that table for you guys, because it's just super helpful, you know, to have, to jot down those, you know, those charts. Okay, anyway, so let's do the z-score. Radio station claims that the amount of advertising per hour of broadcast time has an average of 12 minutes. Average of 12 minutes. Let's go ahead and label that. Average, mean, mu, of 12 minutes, and a standard deviation equal to 2.8 minutes. Standard deviation, 2.8 minutes. You listen to the radio station for 1 hour at a randomly selected time and carefully observe that the amount of advertising time is equal to 18 minutes. So that's our data point. That's our X value. It's just 18. Calculate the z-score for this amount of advertising time. So we're going to do our data value minus our mean, right? How far away is our data value from the mean? Divide it by the standard deviation to get a z-score. A z-score allows us to kind of compare apples and oranges, right? Because if I want to talk about something that doesn't have the same general mean and doesn't have the same general standard deviation, I can't do that unless I'm looking at a z-score. All right, so again, with your order of operations, just be careful, right? I'm going to do 18 minus 12, then I'm going to hit enter, then I'm going to divide by 2.8. Or if I wanted to do it all at once, I'd have to make sure that I had the 18 minus 12 in parentheses, then divided by 2.8. Okay, but either way, I'm getting 2.1428 blah, 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 which we go to one more decimal place than what we had there. Okay, 2.14. All right, hold on just 1 second. Hold that thought. Thank you so much for your patience because we've gone over on time. I'm multitasking here, but all right, I'm back. We're going to keep going. We're almost to the end. Okay, z-score, we did that. Okay, find the 5-number summary. Okay, so again, plug it into the calculator and it's going to spit this information out for us, right? So remember that your quartile 2, your second quartile, that is your median. right? So when it's not this data set, but I'm just going to have it go ahead and calculate. Oops, sorry, calculate, just so that we can be reminded of what it provides for us. So it provides your minimum value, right? That's what they want, the minimum value. Then they want your first quartile, which is 14. Then they want, I mean, again, this is not this set of data, but in this, your first quartile is 14, your median, which is your second quartile, and then your third quartile, and then your max. So it puts them all in order there for you, right? 1, 2, 3, 4, 5. That's your 5-number summary, right? And then remember what that actually means, right? So when we talk about the median, so like if this is all of our numbers, the median is the number that's sitting right in the middle, okay? And then your first quartile is 25% of the data is less than that. First quartile. Median is your second quartile. 50% of the data is less than that. And then your third quartile, 75% of the data is less than that. And then you could also talk about it the other way, right? 25% of the data is more than your third quartile. 50% of the data is more than your median or second quartile. 75% of the data is more than your first quartile. So always keep in mind what these terms actually mean. We don't want to just memorize, oh, Q1 is this. We want to understand what they mean. I'm just kind of flying through just so that we can finish this up because we're so far over. Okay. So, unusual and usual. I think we only have 2 more problems to go through. We won't go this far over next time. I'll be much faster next time. But okay, the ages of the winners of a cycling tournament are approximately bell-shaped. Great, we can do all sorts of things when they're approximately bell-shaped. The mean age is 28.5 years. Okay, so mean 28.5. Let's go ahead and label that. With a standard deviation of 3.3 years. All right, the winner in one recent year was 36. First thing they want you to do, transform that 36, that particular data value, that X value, transform it to a Z-score. So we're going to use our formula, right? Our formula says that the Z-score is the data value minus the mean divided by the standard deviation. Okay, so we're going to do the data value minus the mean, right? We're saying how far away from the mean was this particular data value, and divide it by the standard deviation. Okay, so we do 36 minus 28.5 and divide by 3.3. 2.27, and they've just gone, I think they said specifically to, yeah, 2 decimal places, so 2.27, right? Okay, so that's our Z-score. Now they want us to interpret the results. So an age of 2.27, standard deviations is blank the mean. Oh, it's way down here. Sorry, I was like, where is that? It's above the mean. So let's graphically, let's look at this, right? See, what are we looking at here? So our mean is here. It's 28.5. The particular data value that we're looking at of 36, it's more than 2 standard deviations from the mean. So we can go 1 standard deviation in each direction. We can go 2 standard deviations in each direction, but this data value is over here. It's more than 2 standard deviations. In fact, it's 2.27 standard deviations. We had to go 2.27 standard deviations to the right of the mean in order to get to this data value, this age of 36, because 28.5 is in the middle. We have 36 over here. We had to go more than 2 standard deviations in order to get there, right? That's why it's above. It's not less than the mean, it's above the mean. Okay, now they want you to determine whether the age is unusual, right? So remember, that's not just an English word, that has specific numerical meaning in statistics, right? So if we're dealing with these bell-shaped situations, then -2 to 2 standard deviations from the mean is unusual, okay? If I can go from here to here, everything inside of here is usual. But if I hit 2 standard deviations or go beyond it, if I hit 2 standard deviations or go beyond that, that is unusual, right? Unusual. So kind of making that a little bit prettier maybe. 1, 2, 1, 2. Anything within is usual. But we can go even farther, and they didn't ask it in this one. 1, 2, 3. Anything beyond 1, 2, 3 is not just unusual, but very unusual. Right? That's the terminology that they use. Okay, so it's unusual because it's outside, it's beyond 2 standard deviations from the mean. Okay, all right, and then this last one, kind of bringing a bunch of stuff together here, right? Okay, we've got a table that's giving us some values. Population statistics for the ages of best actor, best supporting actor, for winners at an award ceremony. Distributions are approximately bell-shaped, and then they want us to compare the z-scores, right? We were talking earlier about comparing apples and oranges. Hang on just one second. All right, so they've given us these numbers. They want us to calculate the z-score for the winners in one particular year. So for best actor, the mean age is 41, and there's a standard deviation of 9.2. For best supporting actor, the mean age is a little bit older. It's older, it's 55, and it's got more deviation, right? The standard deviation is bigger than it is here. There's more variation, okay? All right, in a particular year, best actor, so in this category, the data value that we're looking at was somebody who was 40, so they were a little bit younger than the mean, and the best supporting actor was 82. So they were quite a bit more than the mean. But also keep in mind there's more variance in this, right? Standard deviation is bigger than over here. All right, determine the z-scores for each. So for the best actor, we go, let me move this over a little bit here. So we have x minus the mean over the standard deviation. Over here, we have x minus the mean over the standard deviation. We plug these into our calculators and we get these values. Now you'll notice that the best actor is a negative value because they are to the left of the mean, right? They are less than the mean. That's why it's negative, right? If we're looking at this, we have our mean over here of 41. This data value is to the left. It's a little bit to the left, where here we have our mean of 82, or I'm so sorry, the mean is 55. Apologies, getting ahead of myself. Mean is 55. This data value is to the right of that. It's 82. So that's why it's positive. Okay, now they want us to interpret this. So the best actor was within 1 standard deviation below the mean, right? So if we have the mean of 41, if we go 1 standard deviation to the left, so I'm going to label this a little bit better this time. If we go 1 standard deviation to the left, 41 minus 9.2, oops, 41 minus 9.2, not 1, is 31.8. Okay, 1 standard deviation to the left is 31.8, and we didn't even need to go that far. We just went a little bit to the left. So 40 is within 1 standard deviation of the mean. It's a little below, but it's not even a full standard deviation below. Whereas with the best supporting actor, and again, I'm going to kind of draw this a little bit bigger. The best supporting actor, we have our mean of 55. Now our standard deviation is 12. So if I go 1 standard deviation to the right, I have 55 plus 12. That's going to get me up to 67. We got to keep going. We're going to go another standard deviation. That's going to get us up to 79. And we got to go yet again to get 91 so that we can plot where 82 is. 82 is somewhere between here, right? It is 1, 2, and some change. It's more. It's 2.25 right? It's 2.25 standard deviations to the right of the mean, right? So the best supporting actor was more than 2 standard deviations above the mean, which this is organized all weird. Oh, there it is. I'm like, where did the answer go? There we go. I'm looking for the word is, which is unusual. In fact, it's very unusual. Okay, let's fill this in just because the way that this is written is kind of weird. So, right, we're interpreting this. The best actor was less than 1 standard deviation below the mean, which is not unusual, right? 2 to the left, 2 to the right, anything within that is not unusual. That was for best actor, but the best supporting actor was more than 2 standard deviations above the mean, which is unusual. In fact, it's very unusual. Well, no, I'm sorry, it's not very unusual. We're less than 3 standard deviations, but it's unusual. Okay. All right, so I know we flew through a bunch of those. Like I said, I'll get better at pacing with these as we go through this semester. And again, you can always go into the Academic Support Center. You can always reach out to your instructor for clarification. You can do the online chat through the Academic Support Center if you can't physically go in. All right, well, I appreciate your patience as we go through this. And yeah, next time because it is important for us to kind of keep to the time schedule because I know a lot of people, you got a lot going on in life. Maybe you have a job, maybe you're trying to do this during your lunch break. So I will be more conscious of the time next time. But I'm glad that you feel much better about this information. And yeah, if you're ever on a campus where I am, feel free to come see me. So I'm in Palm Coast on Tuesdays. I'm in New Smyrna on Mondays and Wednesdays, and I'm in Daytona in Building 115 on Thursdays and Fridays. So, all right, I'm going to go ahead and end the meeting now, but don't hesitate to reach out to me, to any of the learning specialists at the Academic Support Center, or your instructor for more clarification. All right. Okay. Good luck, and I'll see you next time. Bye.